Okay, so more ESS statistics. And today, what we're going to do is we're going to look at making a survey and then analyzing the results of that survey using chi-squared. It's another statistical test. And so I'm going to take you through an example survey, and we'll do an example of crunching those numbers using a chi-squared. And then when we're done, you'll take a look at your own. The documents that you'll need for this, you can find in our Google Drive folder. It's taking a second to come up, but if you look, go to our ESS, go to IA stuff, statistics, and then there's a new folder called Survey and Chi-Squared. So in there, you're going to find, here's the document that or the slideshow I'm talking through, the survey that I'm actually using, and then there's some practice and some survey tips you'll see along the way. I'll show you where those are. Okay, so now, we use surveys in ESS to collect quantitative data. And these surveys could be asking a number of different things. It could be, you could be finding out how much people know about the environment, how much they care about the environment, how worried they are about the environment. It could be, how many times do they eat meat, or a whole bunch of different ways that you can use a survey. And then, so we have this sort of dependent variable that we're trying to judge with those types of questions that we can then compare two groups or two or more groups as to how they respond to those questions. So, and then we'll use that chi-squared to be able to determine if, being part of this group or that group will alter how you end up responding to the survey. So, in general, here I'm going to give you an example of our research question that we're going to go over today. So, does the year a student is in ESS affect their attitude about climate change? So, what we're going to do is we're going to compare 11th grade students and 12th grade students who are taking ESS to see if they have differing attitudes about climate change. This could be, the groups could be, a number of different things. You could be comparing vegetarians to vegans, or vegetarians, vegans, and omnivores. You could be comparing males to females, whatever that may be. So with what you're going to find out about them, our null hypothesis for the chi-squared is that the group, so in this case, the ESS year, that how they respond to that survey, is independent of that grade that they're in. So the ESS year a student is in is independent of their attitude about climate change, according to the survey I'm going to share with you here in just a moment. But what we'll do with the answer to that is we'll calculate a chi-squared test for independence, and that's going to give us a p-value. And similar to our ANOVA is that if our p-value is less than or equal to 0.05, we can reject the null. So we use that 0.05 for p-values for t-tests, for ANOVA, and so on, and these chi-squared. So if we reject the null, it would mean that actually different year groups have differing attitudes about climate change, or at least they're answering the survey a little bit differently. So let me show you this survey. This survey, if we just look at the questions, the first question on the survey that I asked was, sorry about that. So the first question of the survey I asked is basically my independent variable. Are you in 11th grade or 12th grade? And then the rest of the questions are on what's called a Likert scale, and it's asking us, what are the effects of climate change? Are the effects of climate change are too far in the future to worry me? I have a role to play in preventing climate change. It's not worth ISP trying to combat climate change. For each of these, I'm asking the students to either say they strongly disagree, strongly agree, or something in between. So they would fill out this scale, and eventually we'll get responses that we can analyze. We can quantify the results. Okay, so what we're asking essentially is if you are in 11th grade or 12th grade, is that going to change how you respond to this survey? Okay, all right. So that's the survey. Let's just talk quickly about creating the survey. So in creating a survey, first you have to decide what you're going to measure. In this case, The survey that I've got is kind of measuring your attitude towards climate change. Are you worried about it or you're not worried about it, and so on. And then, but you also have to decide on your groups. What are you comparing? Are you comparing, males to females, 11th to 12th grade, kids at this school versus kids at that school, and so on. So the first question on the survey is going to be asking, putting the participants into that category. And then the next question is going to be measuring, that's the rest of the survey, the next question. So we're going to use a Likert scale to do this, and because that's the most straightforward. So it's this 1 to 5 scale. And when you're creating your survey, there are some tips that I highly recommend looking into that Mr. Crane has put together about how to make a valid and reliable survey. So if you click on that link, it's going to take you to his tips, and you can see these things you need to consider when you're writing it. What's the aim of the survey? Do your questions link to the aim? Are you only asking one question or not multiple ones? Have you defined any important terms? There's only 5 options, and we'll look at what those options would look like. Have you asked similar questions so you can see if people actually are just kind of randomly clicking or if they're actually reading the question? And you always want to get some feedback on your survey. You would want to, if you were doing this for an IA, you would give a sample survey out and have people look at it and tell you, oh, this question was ambiguous, or this one was more clear, or I didn't understand what that term meant, so on and so forth. Okay, so when you are creating a survey, you definitely want to consider these things. And a little bit on that Likert scale that I've mentioned a few times here is that this is a 5-point scale. And so your respondents are going to answer questions based on 5 different categories. How much do they agree with a statement? So that might be they strongly agree, undecided, disagree, strongly disagree. And you can see that the survey that I put together here is strongly disagree to strongly agree. So, how do you feel about that? So that's what we are surveying there. But you can also say, how frequently do you do something? Always, frequently, occasionally, rarely, never. You could look at how important something is to someone. You can also look at how likely they believe they would do something or that something would occur. So, do you feel like that's always true, or would it happen often, not often, so on and so forth. So there's kind of these basic categories. You just realize that you're going to be in a scale from basically strong in one direction to strong in the other direction, and everything kind of in between. Okay, so once I've had students take the survey, you'll get responses. And right now I only have responses from the 12th grade group, but we'll get more with the 11th grade group tomorrow. But you would go through and you would look at the questions, probably need the individual questions, and you'd count how many, responses that you would have were they, how many strongly agrees versus how many strongly disagrees, and so on. So in this case, you can look at first just the survey as a whole, and I'll take a look at this at the end because I think our example, we're kind of look more at just a single question. But for this particular survey, it kind of seems to be judging about how worried or how much control people feel like they might have about the environment, about climate change or not. And so you can kind of group the questions and how they respond. Are they worried, or are they just kind of confused about climate change, or they're not worried about climate change? And so you can kind of group all of the answers into those categories. If you're looking at the individual questions, you can lump those into, I strongly, either they agree, they're ambivalent, or they disagree. So if it were, in this example, the 1 and 2 are the disagrees. So if they, for that particular question, if a respondent said that they strongly disagreed or agreed, the 1 and 2, then those would be lumped into the disagree category. Any 3s would be the ambivalent. And then the 4s and 5s, which is the agree and strongly agree, would be lumped into the agree category. Okay, so if you were to look at an individual question, say this first question here, the effects of climate change are too far in the future to really worry me. So we would have the If they responded a 1 or a 2, that would be disagree. A 3 would be the ambivalent, and the 4 and 5 would be the agree. So that would be how we'd kind of lump those categories together for that question. And essentially what you're going to do is you would go through and count how many 12th graders said 1 or 2, how many 12th graders said a 3, and how many 12th graders said a 4 or 5. And then you go through and tally again for the 11th graders, and you'd say how many 11th graders answered a 1 or a 2, how many 11th graders answered a 3, and how many did a 4 or a 5. Okay, so once you have that count, then you are going to put it into a contingency box. So for this chi-squared contingency box, you would need 2 rows, which is your groups for 11 and 12, and then 3 columns, which will be our categories, agree, ambivalent, or disagree for this question. So here we've got our 2 rows and our column and our 3 columns. Okay, so we've got this little 2 by 3. So now, if I were to go through and count how many 12th graders for, say, question number 1 agreed, were ambivalent, or disagreed, and then I go through and I count how many 11th graders agreed, were ambivalent, or disagreed with that statement, then we can put it into a box. So here is our matrix. So we fill it in, and let's just say we had 25 that agreed of 11th graders, 8 that were ambivalent, and 10 that disagreed. 21 12th graders that agreed, 14 were ambivalent, and 32 disagreed. Okay. So we have all this, but what does that mean, and how do we actually answer our research question, which is, if you're in 11th or 12th grade, is that going to impact how you're going to respond to this survey or not? Is it going to be the same, or just it doesn't matter? So we do that by running a chi-squared test. We're essentially going to plug it into your calculator, and your calculator will spit out a p-value, right? And you'll just see, oh, is the p-value greater than or equal to, or is your p-value less than or equal to 0.05? If that's the case, then you would reject. If it's greater than, then you would accept your null hypothesis, right? Okay, so plug it into you're going to plug a matrix into your calculator. So you need a 2 by 3 matrix. And you're going to then, after you have the matrix filled in, you'll probably have it as matrix A. And then you're using your TI calculator, I hope. And then you go to the statistical functions, right? You choose stats, and you choose the column for test, and you're going to scroll down and choose the chi-squared test. And then that window is going to ask you, do you want to use the observed, which matrix do you want to use for observed? And you would put in, if you put your numbers into matrix A, you would say, put in A. And then you ask it to essentially calculate it. And when you hit calculate, magically, it'll give you a chi-square value, and it will give you a p-value. And the p-value is what we need, and that's what we're going to report. So in this particular example, the p-value is 0.013. Okay, and so that, because of that, we can actually reject the null. So that means that actually, if you're in 11th grade, you might respond differently to this survey than you would if you were in 12th grade. And then you can look at the numbers and say, well, 11th graders seem to agree more often than the 12th graders did. They tended to disagree more often and were ambivalent more often. Okay. So that would be question by question. You can, again, give a composite score that we could lump all the responses as, worried, ambivalent, or not worried. So what you would want to do is go through for each question and kind of decide how their response would fall into, the worried, ambivalent, or not worried. So in this survey, the effects of climate change are too far in the future to really worry me. Well, if you strongly agree with that, then you're probably not too worried about climate change. So you would put anyone who did a 4 out of 5 into the not worried, a 3, ambivalent, or a 1 and a 2, oh, actually I am worried. In the next one, I have a role to play in preventing climate change, what that would mean. So if you strongly agree with that, then hey, you probably are worried about it if you're planning on doing something about it. Ambivalent, or no, you know what, I don't have a role to play. So you would want to categorize, and then you count the number of agrees and strongly agrees. You would count the number of whether you're worried or not, or ambivalent, and that's what you would put into your matrix. So instead of just being the agree and disagree for the individual questions. And that's kind of nice if you do that when you're doing a research, because then you can kind of compare your overall score to some of the individual questions that you're going to evaluate in your survey. Okay, so hopefully the math part on your TI is something that you've done in math class. But I'm sure you can always hit a Google, and I'll try to find a link for you too. All right, so this is how you want to make sure that you're looking at stats if you're going to do a survey, and be sure to check those tips from Mr. Crane when you're writing your own survey questions.